we are going to proceed. Let's look at a very important aspect or section of Numpy. So, of course, it's very important because it is widely in mathematics and science. Of course, I talked about scientific computing. So, we are going to look at what is called Numpy random data distribution. So, Numpy data distribution is what we are going to look at. How data are distributed, just like evenly distributed, want to have it in like an array, one-dimensional array, two-dimensional array, but possibly you have to define the distributions probably in terms of probability of occurrence. Okay, so let's look at it. I'm going to explain the meaning of this just with a simple example, and everything we are going to do from previous class, and we did something like the package called random. So we're going to use that package, and we are going to do a lot of things within that package. It's a package under Numpy which is called random. So if you have not watched the previous video where I started random, you can get back or revert back to the previous video. Okay, so this is data distribution actually, so but I put it as random data distribution. Now let me just say first of all, import from Numpy. Now from Numpy import random. Yeah, so let's import random first, then I'll show you a very simple example. So you want to just generate numbers of possibly of a specific size, you understand? So let's look at it. Let me just call it random. So we're going to use a function inside random called choice. You can see it now, choice. So the first thing we're going to say is this: once this number, let me just take 2 for example. 2, I want 2. Take note, this must take 2 parameters. Understand? This choice must take 2 parameters. So let me give it a size. This size, how many times you want 2 to appear? So you want to get a distribution, and the distribution should have an existence of 2. So I'll put it in quote like this. So 10. Let me just put 10. So I want it to appear 10 times. I want 2 to appear 10 times. Okay. So now I get x equals to stuff. Let me just equate to x equals to stuff, and then I print x. Now let's see what it gives us. This is on a very basic or simple level. Okay, so I click. You see now, you can see that 2 appeared 10 times. Okay, so let's proceed. Let's look at something like this again. Let me just say y equals to random dot choice. Okay, let me just say 2 and 3. Now let me try 2 and 3. So I want 2 and 3 to appear several times, like 10 times. Okay, so I'll have, let me just say 10 times. So that is 2 is going to appear 5 times, 3 is going to appear 5 times, because they're going to take it evenly like that based on my specification or probability of occurrence. Okay, so sorry, there's a mistake here, choice. So there's a quote here. Okay, so let's run it again and see what it gives us. Oh, sorry, I have to print it. Let me print y. Okay, print y now. So let's look at what it gives us. Okay, so you can see now 3, it's randomly packaged, but they are appearing 2 appear 5 times, 3 appear 5 times. 1 2 3 4 5. 1 2 3 4 5. 1 2 3. Okay, 1 2 3 4. Oh, okay, yeah. So the way it appears, let's count everything. 1 2 3 4 5 6 7 8 9 10. Okay, sorry, I didn't specify. So for now, everything is just 10. Okay, so let's put 4 there. You see, it does not, it's not sharing it equally. So, okay, so you can see now it's not sharing equally, but I'm going to show you how to share it equally. So you have to define the probability of occurrence. If one has the highest high probability, then you see that one will appear more. Okay, so let's look at it. Let me just stop in 2 and 3 like this. So let me just run it and see. So okay, we see something like this. Now the next thing we're going to see is this. Want to say, okay, 2 appears much, your probability of occurrence should be higher, then 3 should be lower than 2. So this is how you do it. Let me equate it to set. Now let me just say random dot what's choice. Okay, so I'm going to still use 2 and 3. Yeah, so now I want to define probability. Say p equals to, take note of this, p equals to, so probability is, we have 0 to 1. So means within the range of 0 to 1 we have 0.1. 0.1 is very small probability, 0.9 is high probability, So but if you sum the entire probability, we always give you 1. So in this case, 2 should appear. The probability of 2 appearing, the probability of 3 appearing, add them together is going to give you 1. So let's look at it now. So let me define the probability here now. So let me just say 0.6. Let me say 0.7. So that means 2 will appear much more. 0.3. Make sure it sums up to 1 at the end. So, and let me give a size now. Size of what? Let me say 10. Okay. So 10. Okay, let me close the bracket. Then let me print Z now. Z. Okay. If I print Z, you see that 2 will appear much more. The probability is 0.7 and the probability of 3 is 0.3. So you check now. So you can see that 2, in other words, you are talking about in terms of percentage, 2 will appear 70%. It has a probability of 70% chance of appearance or occurrence. Then 3 has a probability or percentage occurrence of what? 30%. So everything sums up to 1. So you can see now 2 appear much more. So we can also do 3 numbers. I can say, okay, this 5, and that is 3. Then let's say 4 here now. So let me give here as, what do you think going to be if you pause the video to guess? 0.5 plus 0.3 making 0.8. So let's make that one 0.2. So to complete the loop. Okay. So if I run it, you see now 4 appear just twice, 3 appear 1, 2, 3 times. Yeah, 2 appear about 5 times. So that is how it is. So you can increase it. If you want to make it 100, you can make it 100. Okay, you can make it 100. Of course, if you need a larger distribution, fine, you can make it 100. Okay, so that is it. Now let me just show you this. You can also make it like this. Let me just take something. Let me just copy this and just change it so I do not clash the names. We're not here. So let me just take this one as a as the variable. There is a. Okay, so I want to make this one now. Let me just give you a very simple stuff. I want to make it like in terms of 6. This means want to do 2-dimensional now. 2-dimensional. If I do something like this, the size is no longer one single value like 100 like that. It's going to be an arrays, 2-dimensional arrays. That means 3 rows and 6 columns. So let me run this and see what it gives us. So you can see now the distribution is now a 2-dimensional distribution. So if you have this now, it's going to 2 is going to appear definitely 50% chances, this 30% chance, and then this 20% chance. And the distribution is 2-dimensional, so there is going to be 3 rows and then 6 columns. So count it 1, 2, 3, 4, 5, 6, then 1, 2, 3, so 3 rows and 6 columns. So that's where I'm going to stop about that distribution. You can use this one for generations of data in machine learning, generations of data in statistics and mathematics, and maybe scientific research. So you can use this distribution, this random. That's a lot of applications. So in my next video, I'm going to do more on that, possibly going to relate to some deeper aspect of statistics. So just stay tuned, and I look forward to seeing you there. Thank you.